The sky is calm, too calm. The air feels heavy, as if the world itself is holding its breath. Somewhere beyond the horizon, warm southern winds rise to meet cold northern air, and in that silent collision, power begins to form. Tornadoes do not arrive with warning trumpets or roaring thunder at first. They are born quietly, inside enormous rotating storms that stretch miles into the sky. By the time humans notice their presence, it is often already too late. A tornado is not just wind, it is organized violence, a vertical river of air spinning at speeds that can exceed 300 miles per hour, strong enough to lift houses from their foundations, to turn cars into flying debris, to strip asphalt from roads. And yet, they can also be strangely selective. One home erased completely, the next left standing untouched. Scientists still struggle to fully explain this eerie randomness. The story of tornadoes begins high above the earth, inside towering supercell thunderstorms. These are not ordinary storms. They are vast rotating systems that feed on unstable air and moisture. Warm air from the Gulf of Mexico streams northward across the central United States. Cooler, drier air moves south from Canada and the Rocky Mountains. When these air masses collide, the atmosphere becomes unstable, and storms begin to grow upward at astonishing speed. Some reach heights of more than 60,000 feet, taller than Mount Everest turned upside down. Inside these storms, powerful updrafts tilt and stretch horizontal spinning air into a vertical rotation. This becomes a mesocyclone, the rotating heart of the storm. If conditions are just right, a funnel descends from the clouds toward the ground. At first, it is only a ghostly shape, barely visible. But once it touches the earth, it becomes something else entirely. A tornado is born. The United States experiences more tornadoes than any other place on Earth, more than 1,000 every year. Most of them form in a region known as Tornado Alley, a vast stretch of land including Texas, Oklahoma, Kansas, Nebraska, and surrounding states. Here, geography creates the perfect laboratory for violent storms. Flat land allows winds to move freely. Moisture flows north without obstruction. Cold air dives south with equal ease. It is a natural collision zone, and tornadoes are the result. But tornadoes are not confined to America. They appear in South America, Europe, Australia, South Africa, and parts of Asia. Some are weak and short-lived. Others grow into monsters that carve destruction across entire towns. In 2011, an EF5 tornado tore through Joplin, Missouri, killing more than 150 people and causing billions of dollars in damage. Winds exceeded 200 miles per hour. Entire neighborhoods vanished in seconds. For those caught inside a tornado's path, time behaves differently. Seconds feel like hours. Walls collapse with sounds like explosions. The pressure changes inside homes can be so extreme that buildings seem to breathe before they are torn apart. And afterward, when the wind finally releases its grip, the silence feels unreal. A broken planet left behind. Yet tornadoes are not simply agents of destruction. They are also a reminder of how alive the atmosphere truly is. The sky is not passive. It moves, it evolves, it creates energy on scales almost impossible to comprehend. Tornadoes are the visible signature of that energy, brief, violent fingerprints left by the climate itself. And as climate patterns change, scientists are now asking uncomfortable questions. Are tornadoes becoming stronger? Are they shifting into new regions? Are we entering an era where extreme weather will rewrite the map of safety itself? For decades, humans have tried to understand and predict tornadoes, but the truth is unsettling. Even with satellites, Doppler radar, and powerful supercomputers, tornado prediction remains one of the greatest challenges in meteorology. We can forecast the conditions that favor tornadoes, but predicting the exact moment and location of touchdown remains difficult. Sometimes the warning comes 20 minutes before impact, sometimes only seconds. Storm chasers exist in that narrow margin of uncertainty. They are scientists, photographers, and thrill seekers who pursue tornadoes across open plains. Their vehicles are packed with sensors, cameras, and armored steel. They race across highways as storms tower like living mountains in the sky. To outsiders, storm chasing looks reckless. But without them, much of what we know about tornado behavior would remain a mystery. Inside the storm, chaos rules. Winds move in unimaginable directions. Rain wraps around the core in dense curtains. Lightning flashes reveal towering walls of spinning cloud. And somewhere at the center, the tornado moves with terrifying purpose. Even experienced chasers admit that fear never fully disappears. One wrong turn, one miscalculation, and the hunter becomes the hunted. Tornadoes are ranked on the enhanced Fujita scale, which measures damage rather than wind speed directly. EF0 storms may break branches and damage roofs. EF5 tornadoes are capable of leveling entire neighborhoods, lifting large buildings, and throwing vehicles more than a mile through the air. Only a small fraction of tornadoes ever reach EF4 or EF5 strength, but these are the ones that shape history. In 1953, a powerful tornado struck Worcester, Massachusetts, proving that violent tornadoes are not limited to the plains. In 2013, an EF5 tornado hit Moore, Oklahoma, hitting the same city that had been devastated just 14 years earlier. Survivors described winds so loud they drowned out the sound of their own screams. Entire schools were destroyed in seconds. Children who grow up in tornado-prone regions learn early how to read the sky, a greenish tint to the clouds, a sudden unnatural stillness, the distant roar that sounds like freight trains in the dark. In many towns, storm sirens stand like silent guardians, ready to sound an alarm that means everything and nothing at the same time. It means danger is coming. It also means life must keep moving forward afterward. Tornadoes also reveal something profound about human survival. After destruction, communities rebuild. Neighbors help neighbors, strangers become rescuers, power returns, roads open, schools reopen. Life insists on continuing. And yet the scars remain. Empty lots, foundation slabs where homes once stood, twisted trees bent in the same direction like frozen witnesses. Tornadoes change landscapes in seconds, but they change people forever. Beyond the physical destruction, tornadoes reshape how humans think about risk, safety, and control. In a world where technology gives the illusion of mastery over nature, tornadoes remind us that not everything can be commanded. They are deeply local events with global implications. One rotating storm can affect food supply, insurance markets, climate research, and migration patterns. In recent years, tornado behavior appears to be changing. Scientists have observed shifts in regional activity. While overall tornado numbers fluctuate naturally, outbreaks seem to be clustering differently in time and space. Some researchers suspect that warming temperatures may influence storm intensity by increasing atmospheric moisture and instability. Others caution that long-term data is still limited. The truth is unfolding in real time. Tornadoes also exist in places humans can barely survive. Scientists have observed tornado-like vortices on Mars, where dust devils tower miles high across red deserts. On Jupiter, storms larger than Earth rage endlessly. These distant cousins of terrestrial tornadoes reveal that rotating storms are not unique to our planet. They are a universal expression of physics itself. On Earth, however, tornadoes intersect directly with human vulnerability. Mobile homes, aging infrastructure, poor access to storm shelters, all increase the human cost of violent weather. Modern radar can detect rotation within storms, but warnings only work if people have the resources to act on them. In many rural areas, minutes can mean the difference between life and death. And yet, tornadoes also inspire awe. From a safe distance, they are terrifyingly beautiful, a twisting pillar of cloud sculpted by air itself. Sunsets behind rotating storms paint the sky in colors that feel unreal. Photographers capture images that remind us how extraordinary the natural world truly is, even when it is at its most dangerous. For scientists, tornadoes remain one of the last great frontiers of atmospheric research. Why do some rotating storms produce long-lived tornadoes while others do not? Why do some tornadoes suddenly strengthen without warning? Why do multi-vortex tornadoes behave so unpredictably? Each year, field experiments deploy fleets of radars and drones directly into storms, trying to decode what human eyes cannot safely see. In the end, tornadoes exist in a paradox. They are both brief and eternal. A single tornado may last only 10 minutes, yet the atmospheric forces that create it have existed for billions of years. The wind that destroys cities is the same wind that carries seeds across continents. The storm that tears rooftops away is powered by the same sunlight that warms the oceans. When a tornado fades, it does not vanish into nothing. Its energy is dispersed back into the sky. Its story remains in memory, in scars on land, and in the silent respect humans develop for the forces they cannot control. The warning sirens eventually fall silent. The clouds break apart. Birds return to stunned power lines. Debris is cleared. Concrete is poured. Life regrows around emptiness. Rows of new houses appear where nothing stood before. Children play beneath skis that once carried devastation. And somewhere far away, beyond the horizon, warm air is once again rising. Cold air is beginning to fall. The sky is preparing another quiet collision, unseen and unstoppable. Tornadoes are not anomalies. They are part of the living engine of the planet itself. Violent, beautiful, temporary, unforgettable. And as long as Earth's atmosphere breathes, they will return.